In Lesson 3, we're going to look at equivalent ratios. Example 1 says Mason and Laney ran laps to train for the long-distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. So right here, this is telling us the order of the ratio. So we've got Mason to Laney's laps. So when I look at these two numbers, 2 to 3, the order is Mason to Laney. So the 2 would be Mason's laps and the 3 would be Laney's laps. Part A asks us to draw a tape diagram to represent this ratio. So I'm going to draw 2 boxes and label those M for Mason. And I'm going to draw 3 boxes for Laney. Notice that I've lined up the first 2 in each of the ratios, so everything's lined up nicely. Part B says, if Mason ran 4 miles, how far did Laney run? Draw a tape diagram to demonstrate how you found your answer. So now in all of these parts of this problem, it's all going to go back to the idea that the ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. So for each part, I'm going to draw that tape diagram of 2 to 3. Okay, so these are representing laps, each box, because it's the number of laps each ran. And now it's saying that Mason's 2 laps were 4 miles. So it's saying Mason ran 4 miles, so those 2 laps were equal to 4 miles. So next to Mason's bar, to show that, I'm going to write equals 4. In a tape diagram, the idea is that each of these sections are equal to the same amount. Okay, so whether it's in Mason's bar or in Laney's bar, because it's a consistent ratio, each section would have the same number inside of it. For Mason, his 2 laps were equal to 4 miles. Each lap is the same distance, so to figure out how many miles each lap was, I'm going to take the 4 and break it up into 2. So in order to do that, I'm going to show that I'm doing 4 miles divided up over 2 laps to see that each lap would be 2 miles. So inside each section of the tape, I'm going to put 2. Now since each lap for Mason was 2 miles, that means each lap for Laney is also 2 miles. So to figure out how far Laney ran, I'm going to take the number that's inside each section and I'm going to multiply it by the number of sections. So I have 1, 2, 3 sections. So 2 inside each of the 3 tells me that she ran 6 miles. Okay, so Laney ran 6 miles. Okay, so what's interesting here is that this is showing us that 2 to 3 ratio with the number of boxes, but because we've placed numbers inside each of the sections, it's showing us an equivalent ratio. Equivalent ratios just mean equal ratios. So this is also showing us a ratio of 4 to 6. If you were to look at 4 to 6 and you were to simplify it, you would divide both by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Since we've divided both numbers in the ratio by the same number, it is creating an equivalent ratio. So we can say 4 to 6 is an equivalent ratio to 2 to 3. Okay, let's look at example C. If Laney ran 930 meters, how far did Mason run? Draw a tape diagram to determine how you found the answer. So once again, we're being brought back to that original ratio of 2 to 3. Okay, again, it's Mason to Laney. It's very important to make sure you're labeling your tape diagram. So now instead of looking at miles, we're looking at meters. And this time it's saying that Lainey ran 930 meters. So that means the 3 laps that Lainey ran were equal to 930 meters. In order to figure out how many meters Mason ran, I have to first figure out what number would go in each section or how many meters each lap was. In order to do this, I'm going to take the 930, that is going to be this entire bar, and split that 930 into 3 separate sections. Okay, so when I do this, I get 310. So that means each lap was 310 meters. And the same would go for Mason, 310 meters. To figure out how many meters Mason ran, I'm going to take the number inside each section and multiply it by the number of sections, or take each number of meters and multiply it by the number of laps. And that's going to give me 620. So Mason ran 620 meters. Okay, so the next one says, what ratios can we say are equivalent or equal to 2 to 3? Well, we already talked about equivalence back in part B. We said that this tape diagram shows us that 2 to 3 ratio because of the number of boxes, but it also shows us a 4 to 6 ratio. So 4 to 6 was equivalent to 2 to 3. Using the same idea, in part C, it's showing us a 2 to 3 ratio, but it's also showing us an equivalent ratio. And the equivalent ratio is by using what we're saying each bar is equal to. So another equivalent ratio would be 620 for Mason to 930 for Lainey. Okay, and if we were to simplify 620 and 930, we would end up with 2 to 3. Okay, so now the next one is just a little bit different. It says if 1 lap is equal to 3 miles, how many miles did each person run? So once again, the ratio stays the same. It's still a 2 lap to 3 lap ratio, Mason to Lainey. Now this time, instead of telling us a total number of miles or meters that each person ran, they're telling us that 1 lap is equal to 3 miles. So if each box represents a lap, that means in each box would go the number 3. So 1 lap was 3 miles, another lap was 3 miles, this lap was 3 miles, this was 3 miles, and this was 3 miles. So now to figure out how much each person ran, we take the number inside each section and multiply it by the number of sections. So I've got 1, 2 for Mason, so 3 times 2 is 6. And for Lainey, I've got 3 in each section times 3 sections, or 9. So this now shows us that 2 to 3 ratio, but it also shows us a ratio of 6 to 9. So 6 to 9 would be another equivalent ratio to 2 to 3. And if you think about that one, if you divide both of these by 3, it gives you that 2 to 3 ratio.